Great, thank you. So, idea say we're trying to go through is digital credentials, understanding the diversity of the type we've got out there and the latest activity that's happening with them. Clearly, you know, we've already seen this morning from some of the presentations that there's a lot of activity in this space anyway. So hopefully this will build on what we've seen this morning and enable you to tie some of the loose ends together in terms of where the different standards and everything put together. So, again. Microphone back? Yep. So, brief bit about me. My PhD is in rocket science, and I failed to become an astronaut. So I looked around for the next most exciting career I could find, and either I've got limited imagination or there's been really something in this identity that's kept me latched into it. And for me, hopefully it's the latter, and I've been working for about 25 years in a range of different projects, some national identity schemes, others around standards around passports, driving licenses and bank cards. And really the bulk of what I'm going to be covering today is what's happening in ICAO-STANDARDIZED in terms of digital devices that can be used to supplement credit cards. So, physical identity documents. There are still a huge number of them around. You know, if we'll look at what we've got in terms of our world today, you know, we all have passports, credit cards, driving licenses, all physical properties. They're clearly very easy to understand and operate, and they allow for you know, limited machine-readable operation through either MRZs or barcodes or some instances chips that are put onto them. But they do have some issues. I mean, one of them is that they're expensive. So I've just recently applied for a new passport in the UK, and that's well over $130 US. The reason why, you know, that they're getting expensive is because they're trying to build in more security, trying to build in more functionality. So the chips that have gone into them, the different setups that are put in place, all of that comes with a cost. And so it's an expensive thing to put in place. The other challenge you have with them is that you know, they've got all these different documents have got different form factors, different materials, and it's all coming together in a range of different ways. So the challenges, as I said, privacy is obviously one thing. You know, if somebody picks up my passport, they can immediately get a whole lot of information about me that could be very important and enable things such as identity theft. Some information can be encrypted, so you know, 2D barcodes, as Patrick mentioned earlier on, can encrypt some of the data that's put in place. But you know, as a physical document, they are open to alteration or forgery, and some of these forgeries are getting much more extensive and complex. Clearly, you know, they can be lost or damaged, and it's not easy to replace. My passport that I got renewed, the chip had failed in that, and that took best part of 3 weeks to get a replacement one back in, which, you know, was inconvenient for me. And they're also inconvenient to carry. You know, in particular, one of my hobbies is I go to festivals, and a muddy field with a passport or some other form of identification is not a recipe for success. So, okay, we've got them here. They're an important element. They're part of our toolkit, but you know, how can we supplement them? And we're really looking at moving into, you know, digital or verifiable credentials for personal identification. You know, really what this means is we've got a digital representation of a person. We use them in similar sort of like use cases to physical credentials, but they can be stored and displayed on smartphone or edge devices, or even just accessed across the cloud. So much more freedom in terms of how they can be picked up and used. So the source systems that we've seen to date have been very much centralized systems, and they come in sort of like a couple of main categories. There's one which is sort of like a corporate one, so Amazon, Facebook, all of those different organizations are putting together centralized identity systems. The others are national schemes, and I've just listed a few here, but you know, they are starting to become much more widespread as people see the benefits and advantages of going down this route. Some of the key things that we can point to in terms of the centralized digital identity schemes, the advantages that come from them are, large take-up. I mean, okay, in some instances, they're mandated that you go through this process, but the fact that you've got something rolled out across your population means that you can start to make some huge savings and also increase the convenience of those that carry them. They can get benefits out very quickly. Again, because of the fact that they're pretty much unique and you made a categorization, you can work on them. And they really do help reduce cost and complexity. So again, the Indian scheme that I mentioned before, their prediction, is that they're already saving, billions, but they are also being able to pick out identity fraud and make sure that doesn't happen. And Estonia, and we've got a representation on this later on, they're saying that 2% of their GDP has been saved by moving over from physical documents to digital ones. So there are some huge advantages in terms of these centralized systems, but there are some challenges that come with them. Most of them are associated with, say, the corporate systems, security vulnerabilities. There's very little that's done in terms of rigorous checking on some of these things. I've got 3 accounts on Amazon, primarily just to cut down the amount of junk mail that I get sent through from them. And so, that's a very easy way of getting multiple accounts into a system. There are also some sort of issues around data sharing and privacy. And clearly everybody in this room is familiar with what happened with Cambridge Analytica and the Facebook data that they collected, then harvested and then sold on. Now, interestingly enough, none of that was actually against the rules of what they did at the time, but clearly it raised a whole lot of ethical issues. And the ethical issues run right across the scheme with these sort of systems. If you've got a centralized corporate system, where's the data stored? If it's not stored in your home country, then it may have different rules and regulations about what can be done with it. So it's an important thing to keep track of. When we come to the national systems, clearly there's a lot more issues around security and process vulnerabilities because of the numbers. But again, those things that can be controlled and can be brought into line. But one element that tends to come in when you go from a corporate system to a national system is it's sometimes based around biometrics. And clearly, if you have a data breach, biometrics can't easily be reset into a program. So there are some mechanisms out there, such as cancelable or revocable biometrics that involve, convolving images and storing different form factors to get them across. But it can be a challenge. So, moving on, again, we've got these systems in place, they supplement the physical systems, but, once we go to decentralized systems, we can start to get some real new use cases coming in. So, just a key thing that you can do with that is to secure the information such that you, as the holder of the card, have control over who gets access to the data that you got stored on it. So, different use cases can be envisaged. For example, if I go to, a pub or a bar and I've got to prove I'm over 18, I haven't been challenged for a few years, but if I did have to prove it, then I could use my digital card to show just that I'm over 18, not give away any other information as to what my name is or my exact date of birth, but just prove that I meet the use cases requirements for setups. And all of that can be done very easily on some of these systems. And the phrase that's been thrown around is sort of like self-sovereign identification, the ability to, you as the user, keep control over who sees what in terms of your data. So, like I say, clearly a lot of advantages. Everything's machine readable, so you've got open and interoperable setups. You can do offline bilateral communications, and you can interface some of these credentials in with very user-friendly wallet apps on common devices. So most of the major manufacturers now have a wallet function. Now, it's not able to go across borders in some instances for certain applications and not to use government-issued credentials, but it can make a huge convenience factor. So, where they're going to be most valuable, where you've got fast machine verifiable exchange of information, where you've got your centralized identity management systems, can't achieve the adoption rate due to lack of trust. Once you've got that over that trust hurdle by handing over control of your data to the user, then you can start to get some of these things coming in. So all of these are really valuable add-ons to our toolkit. So we start from physical, we go to centralized, and we've also got decentralized now. All of them has a role to play and have different use cases and what we're trying to do. The decentralized one, our first involvement with them came with some of the COVID-driven emergency responses. We had a very quick need to actually have the ability for me as a user to actually identify that I'd had the vaccination when I wanted to enter a particular room. And these were very rapid setups. They were put in place very quickly. Most of them have now gone. And that was really due to the mainly immature and non-standard technical approaches. They were very popular, and they have done a fair bit in terms of changing the public perception to the usefulness of these sort of setups, and that's what we've been building on with some of the work that we're doing. Key activity, and I think that this one's going to come out probably next year, is the EU Digital Identity Wallet. And this is really scoped to cover a whole raft of use cases. So e-government services, banking, but employment, education, healthcare, and travel. All of these things built into one particular wallet that will cover, certainly initially, the 27 countries of the EU. The program's been underway since 2021. And it was established by the legal regulations, and this is an important activity that needs to go in parallel with any of the technical work that goes on. They do need, so in terms of the challenges, we do need to be able to address the legal frameworks, and we need to make sure that, if we're starting to look at these things to go across different jurisdictions, how we actually handle those sort of setups. The take-up and adoption rates are still early. It's still early days at the moment to decide on these things because a lot of them haven't been rolled out, but they'll certainly be an important part of what they're trying to do. But another key element is trying to understand the business model as to how they come about and how they actually can be supported or self-supporting in their operation. So all of those are needed to get across this final hurdle of making something that's usable and friendly. Like I say, the biggest piece of work at the moment that's going on around the EU, just point out the fact that this stuff isn't global. So what I'm going to go on to now is some of the activity we're doing in SC17 to try and take some of these credentials that can go into the digital wallets and make them global and make them completely interoperable. So SC17 and identity, we've got a whole raft of different things here. There are 18 billion bank cards in circulation at the moment. All of those conform to the standards that are put in place by SC17. And that's why I can come to a new country like Ethiopia knowing that what I've got in my pocket will work the same as it does when I get back home. Passports and travel documentation, we're going to get more on this when we come across to our partners in crime in this, which is ICAO. But driving licenses are a key element, and this is the application that's been used to really forge some of our work around this mobile driving license activity that's going on. But we're not stopping there. We've got drone licensing is the new application that's coming in, and this is licensing for the drone, but also licensing for the pilots to make sure that when you've got people flying these devices, that they've got a clear credential that enables them to do that. It's the other activities within SC17 is really all around the infrastructure that's enabled to make these things happen. So, our widely accepted standards and infrastructure, that's key to what we've got. But we're not static. And I've just put up here the use cases around bank cards. In the early 1920s to 1950s, there were basically limited acceptance to ubiquity is the sort of journey we went on with those. But the materials we used went from paper to cardboard to plastic. Now the plastic one that came out in about the 1950s, 1960s is very different from the one you see now. But once we started to go down the route of saying, okay, well, how can we put electronic or magnetic stripe interfaces into some of these things, that forced us to bring on board a whole new range of technologies and make sure that we could adapt to them. And the modern use now is, I say, really all looking about how we can enhance the security on them, so the chip and pin codes, and we have some interesting discussions on the way through. For example, one of the things that we're looking at the moment is that bank cards, that the long number across the bank card has 16 characters. Turns out we're running out of those numbers. So, we're having to go through a process of trying to work out how many people we can offend by just saying we'll put a couple more characters in and see how everybody's readers don't work. But that's one of the challenges we're looking at. But also, say, looking at these online mobile devices, got to be key for us, and that's an area that we're working on very hard. So this one about the mobile driving license is really what we're trying to get as a global credential that will be government certified and able to be picked up and used by anybody with different wallets, and also interoperable. So it's a great standard that we're working on. It's the 180113 set of standards if you want to look these things up. But they're currently based on entirely the same infrastructure that we've got in place to support all the other activity that we've got. So we have two working groups, Working Group 8 and Working Group 4, that are all just about putting that infrastructure in place. So to give you an example of how things are at the moment, this is if you try to hire a car in the UK, I've got to provide my national insurance number, I've got to provide my driving license number, I've got to supply effectively my address, and if I've got connectivity, I can get a timestamp code that enables me to go and do something with it. Now, there's nothing tying that code to me. If somebody else has that information, they can get exactly the same code, go and hire a car, and leave me with the problem of trying to pick up the identity theft. So it's not very good at the moment. So that's one of the motivations why we're hoping to get this driving license working more effectively through a mobile device, is such that we can actually start to improve security and use cases. So, what we're trying to get, secure encryption and all the security features we need to make this thing very low risk in terms of identity theft and counterfeiting. We're looking for, convenient, easy access of information, but again, only the information that's relevant and only to those people that are entitled to see it. We want to have this selective sharing across the whole setups, and the final sort of area we're looking at is if we can get this set up, we can have this as a truly global standard that can be picked up by anybody's wallet and displayed and have the same sort of capability. The other thing to point out is that this is the first of the groups that we're starting to work with. We are starting also new operations around tying together some of the work around passports and travel documentation. So there's a couple of things outstanding on this thing, and this is really why it's not going to roll out for a little while, but test and accreditation is going to be a key thing. But the final thing that we've got to get nailed down is the business models for adoption, because we've got different groups working in this area. Each of them has their own requirements for how the business makes. I mean, ISO makes its money from selling standards. Clearly, it wants to make sure that it can get its revenue stream coming in from that. But the EU has mandated that there can't be any charge in these activities. So there are some areas that we're trying to work through. So that's what I was just going to try and give as a brief introduction. As I said, my partner in crime in terms of the mobile, in terms of the passport, is ICAO. We're very fortunate to have somebody from ICAO on next to give us the run through their activities that are supporting this activity.
Okay. Well, thank you, Dr. Waggett. And I think one thing for sure is I'm going to tell my kids that I was introduced by a rocket scientist. It's a first for me. So thank you, first of all, to Dr. Attic for the invitation to ICAO to speak here. And also thank you to his excellent team for the organization of this seminar. My name is Christopher Hornick. I'm from ICAO. I'm from the facilitation section. Previous to my work with ICAO, I was at IATA in the facilitation section. And before that, I was working with the Organization for Security and Cooperation in Europe. Also on travel document security, work with ICAO and Interpol. So I've spent my career in this space. So I have the task to speak about the digital travel credential from the ICAO perspective, or more precisely the ICAO DTC specifications. And I will end with a few slides on barcodes, which I think is a good transition to our next speaker, Patrick Grother. And, but before I go on, I just wanted to say very clearly that from the regulatory standpoint, the DTC is not an obligation. Yeah, that's clear. I just wanted to make that statement, and I also want to make the statement that the electronic machine-readable travel document, or the e-passport, is optional. Yeah? We have more 150 states that have gone that path, and that's fine. There's some issues to be resolved there, but the investments there are a choice. It's not a requirement, and the same is for the DTC in that sense. So, what is a ICAO DTC? It is a what we would say a secure and globally interoperable digital companion, or a substitution to a physical EMRTD. And of course, the idea here is to support seamless travel, to enhance facilitation, but also it needs to be a very secure process. It needs to be as secure as what we have now, if not more so. And it's based on existing procedures and protocols that we have in place already. It clearly also needs to conform with ICAO-DOC 9303, our technical specifications for machine-readable travel documents. All good here? I'm good. So importantly, and I want to take you through this a little bit, is that the digital travel credential consists of a virtual component, or a VC, and a physical component. Okay, that's an important concept, and that is the same concept that exists already for machine-readable, electronic machine-readable travel documents. And through that, the DTC maintains a cryptographic link to the state, to the issuing authority. That's also critical point. Now, unfortunately, there's some added color there in my I don't know why that happened, but in any case, so what is the, now we have to dig down a little bit, what is the existing EMRTD concept? Okay, so we have a virtual component and a physical component. An e-passport can be viewed as a combination of both this physical and the virtual component. That's really important. Yeah? So the virtual component is the data on the chip, in particular what we call within the logical data structure. Yeah, it's like the operating system of the chip, and data groups 1 and 2, where we have the machine-readable zone in digital format, the facial image in data group 2, and the security object. Those three things taken together form the VC, the virtual component, and that's important for a number of reasons. First of all, that VC is subject to what we call passive authentication. So you can validate that content. So you can authenticate it for being, being issued by, through, for example, assisting yourself with the PKD and downloading public key certificates, conducting passive authentication and determining that the data is authentic and has not been tampered with. That's important. Also important is that the EMRTD is not tamper-proof. Yeah? It's tamper-evident. So you will see if someone has altered the data or not. That's important to do those checks. The physical component, so this is a passport booklet with a chip, and it contains, within that chip is the physical component. Data groups 1, 2, and the security object form the virtual component. The physical component, there's also a cryptographic check on that, and that's called clone detection. That's also important, yeah, and proves that, that the passport has not been cloned or replicated through fraudulent means. That's another additional important check at border control, which doesn't always take place, also assisted through traditional means and also through making use of public key certificates from the PKD. Now, about the DTC and how you might want to use it, clearly it seems that this is going to be useful for providing in advance. In advance of travel, or in the case if you're applying for a visa, or an e-visa, or an electronic travel authorization, or even what we would call a digital travel authorization, some type of visa. You may also want to be sharing this with the airline, your airline during check-in, or potentially even already at the booking stage. But here I've highlighted the VC, yeah, because what you're sharing and submitting is the file, right? You're not submitting your phone or your passport. You're not FedExing that in and getting it back. You're submitting the virtual credential, the virtual component. Okay? That's an important of this equation. And then it's the border or the state which has, should be doing passive authentication on this file to determine its authenticity. And in theory, the private sector, the aviation sector, can do the same through commercial access to the PKD. They can also perform passive authentication on that file. So, the file or the virtual component, it's been specified, it's been approved already in 2020. So, the VC is a file that can be stored on any data medium and does not have any access protection, right? So basically, it's being extracted from your booklet, from your chip, and being placed, for example, in a phone, in a wallet, and then the passenger is sharing that file in advance of travel for facilitation purposes. So ICAO is also working on and has published a specification for the physical component for DTCs. And that one closely reflects the current interface to inspection systems. Now, the progress on the physical component is not overwhelming in that sense, and that was improved in 2022. And this will become a little clearer through my next slide. But the physical component of a passport booklet, the chip in an EMRTD, also counts, obviously, as a physical component in combination with a VC that has been extracted and put on a phone. Obviously, the big jump here would be to define other form factors such as the mobile phone, so that the mobile phone can act as the physical component. My estimation, I'm not involved in those discussions, but in my estimation, that's still a couple of years away. Okay, so we've had a couple of pilot trials on especially what we call DTC type 1, where we use the passport booklet and we extract the virtual component. And those have been done in Croatia, Finland, and the Netherlands. And one of the outcomes of these projects have been the recognition of the need to secure a little bit more the transmission of the file, right? Because once it's extracted, there's no access control. It goes from your private device to a portal or some other entity, an airline or whatever, is ingesting this data. But the transmission of this information is not secure on the one hand, and on the other hand, it's also not completely interoperable or standardized. Importantly, the Finland project also included some analysis on what we call defects in EMRTDs. And that's also a very important step as we go forward. We have to recognize the fact that not all e-passports are issued correctly. There are errors or defects, and that causes problems during passive authentication or authenticating the data. And those problems will go forward into the DTC in the same way, which will lead people to manual processing, and the facilitation aspects of that will not be so clear. There's a new round of EU-funded pilots, which are being prepared in Finland and the Netherlands, and we will be studying those, especially in terms of interoperability, in terms of which kind of wallets can be used to send your VC to different states operating different types of schemes of the Type 1 projects. Okay. Now I want to have a quick overview of our types. So the overarching framework has been set for the DTC. Now, the DTC Type 1 is very, very strongly based on the existing framework where the e-passport is used. The e-passport contains the physical component, the chip. It already contains the LDS and the data, and the VC is created from the passport. And as we noted, the VC is a file. It can be stored on any data medium, so you inject it into your device, and then you share it from there. The physical passport, e-passport, remains your physical component, and essentially you must use this or must travel with the passport. So for example, in the Finnish model, supported through API and PNR, there's a gallery. The border inspection system knows this person is arriving. The person goes through facial recognition. Through that, the face data pulls up the VC data, and then the passenger simply taps the passport booklet, and that can be done without opening the booklet because the VC data is there. And then they conduct the anti-cloning check within a split second. Apparently, they've gone down to 8 seconds in that pilot on processing, so that's considerably better than automated border control, even, and definitely better than manual desks. Now on Type 2, so we're not fully there yet in the sense of using the phone as the PC, because it's simply not yet approved by ICAO, by the NTWG, and the discussions there are ongoing within ISO, especially Working Group 3 and 4. But the theory there is that the virtual component is created from the eMRTD chip, but the issuer is placing it directly into the physical component, a physical device apart from the e-passport. So in that sense, where we would argue the passport exists and should be accompanied by the physical, the passenger should be accompanied by the physical passport during travel. But let's say in the Finnish example, the VC has been submitted in advance, facial recognition is done, assisted through passenger data, and then the passenger simply taps his mobile instead of his passport. So in that sense, honestly speaking, the additional reduction in processing time will be very minimal. But of course, it does provide additional convenience and potentially some additional security as well. But that would be reliant on all those anti-cloning measures and checks on the physical component, also on the phone. Type 3, I won't say much about this, but the idea here, I think that the use case would essentially be in an emergency type of a travel document situation where a consulate could issue a virtual component onto a device, a physical component device, an approved device, without a passport being there, without a passport having been issued. And in theory, this would have a limited validity period. So some challenges and next steps in that sense. Again, I want to stress that, first of all, the virtual component is a file. The virtual component is subject to passive authentication, just as the passport data is now. And the passport booklet, or the physical component, in that sense being the chip on your passport, or potentially in the future, the phone is subject to higher security in terms of clone detection. And that is an important security measure that really needs to be in place and defined for other form factors. It's defined already now for the passport booklet and the chip. And in terms of approving the telephone or the mobile device, I won't say all too much because I'm not privy to those discussions, but they will be held over the years, I think, within ISO, WG3 and 4, and to establish parameters of security for the mobile device. But definitely, as a take-home message, ICAO has not created specifications for mobile devices yet or approved the mobile device as a physical component, which is not to be confused with the fact the mobile device can host the virtual component. Okay? You're using your mobile device under type 1 to extract the file, the DTC file, and share it. And then a few words on barcodes. So barcodes, really, we came through, made some improvements and transitions within the pandemic. That had been, and by the way, this was initially was previously called the visible digital seal, and I think a lot of people refer to it still as that. In fact, that's what part 13 of Doc 9303 is called. Then during the pandemic, we realized that the VDS on the visa sticker had limited real estate, but these other health proofs, for example, proof of vaccination and so forth, or a digital travel authorization has more space. You could put more data on there. And that led to some improvements. But anyway, I want to make sure to mention a couple key points, that the barcodes, which we now call ICAO data structure for barcode, IDB, that provides a security, so the barcode, a 2D barcode, provides a security improvement for what would usually be a paper-based document without a chip. And that leads me back to the other argument I was making. So if you don't have a chip, you can't do cloning checks, but you can do passive authentication checks, again supported through the PKD and access to the exchange of certificates via that global repository. So this reuses the trust framework for electronic machine-readable travel documents with a root certificate, in this case a barcode signer, and a signature that can be checked offline, including by border control, as long as that root certificate is in place and has been downloaded, for example, from PKD. So we had current specifications over the years had been developed for what we would say VDS for non-electronic documents, which would have been on the visa sticker. Then we had VDS for non-constrained environments, which is when we had more real estate. For example, on the COVID vaccination certificate, the barcode was bigger, could hold more information. And we also have secure messaging barcodes, which assist with the access control mechanisms to machine-readable travel documents. So what the IDB is doing is creating a common data structure for barcodes defined by ICAO, and then we have different use cases within the IDB. And very importantly, the next iteration of the TR will incorporate the portrait image, or has the ability for the portrait image to be incorporated into the payload of the barcode. And some of the use cases certainly are for the visa, the digital travel authorization, and for emergency travel documents, for health proofs, including testing or vaccination proof, or even a proof of recovery. This was quite a challenge during the pandemic. Also, it can be used potentially in the future. It may supplement or also replace the machine-readable zone. Potentially, probably use case first on TD1, on identity cards. And specifically for identity cards, it can be used to enable or to do away with the need to flip the card during reading, because the machine-readable zone is on the back of a TD1, but the access control mechanism is on the front. And if you put the barcode, I think, on the front, there's no need to flip the card. So there's some other benefits that are coming out of this standardization work. And I wanted to conclude with a little bit of a push or an awareness raising for, and here's some added ink in my presentation, for the DTA. And this is something that is important, I think, also in terms of terminology. You hear a lot about e-visas over years, and we're trying really hard to move away from the term e-visa. And then we have the term electronic travel authorization. For us, that's something else. That's something supported by what we would call interactive advanced passenger information, where there are checks, system-based checks, like an ESTA, which does not have a barcode, right? So that's just a notification. So showing that to the airline is not really, there's nothing to check, because they're doing it systems-based. They're sending the passport to CBP, and CBP tells the airline, yeah, this person has an ESTA. But in the case where there's no transmission, there's no interactive communication, we're looking to standardize or supporting states in standardizing the barcode, right? Because if you as a state issue your visa, or your e-visa, essentially, probably you're the only one going to be able to read that barcode, right? Not other actors, including the airlines or other states, for example, of transit, will necessarily want to invest into your trust framework. But if you build it on the ICAO trust framework, you can distribute your keys via the PKD. We enable commercial access. The airlines and service providers can push that out, and states of transit can also validate barcodes. Yeah? So that would be, that's my presentation, and thank you very much.
Thanks for that. Just to give a quick reminder, though, that we're going to try and go through the presentations first, but pick up questions on the way through, and we're going to be using the Slido again for any questions. If there's anything in particular I'll spot on the way that is for a particular speaker, I'll pick that up, but failing that, we'll work our way through. So just remember the Slido and put the questions in there, please. And I had a request from Otto at the end that he wants the difficult questions. So hear me? Speaker is Patrick Grother from NIST, and he's going to take us through some of the activity they've been working on.
Right, thank you, Peter. So my slides were there, and they are back. So this is a very well-defined topic that I'm going to talk about now. Can you store face photographs inside 2D barcodes, QR codes? There are other standards, but QR codes have got marketplace dominance, it seems. The short answer to this presentation is that yes, you can. You can maintain face recognition accuracy at very high levels. How you do that is the subject of what I'm going to talk about. So that QR code that you see is an HEIC file. An Apple phone supports HEIC for its photographs, but it doesn't support reading QR codes, but it could. So this is the most important slide that we have here, and 3 ways of encoding data on QR codes. What you'd like to do is prepare a compact face image. They have to be small to do this because the QR codes can't be too big. Can you prepare an image using very standardized and put it on a QR code and then decode it into a human interpretable, human visible image? Yes, you can, and you can do that with standardized tools. Now, there's a marketplace out there already for a few years now, which have used proprietary face encodings. They could be standardized compressors, but you need the vendor app to do it. They could be exotic neural networks that are compressing the face to a small size, and they would be non-standard, high-performing but non-standard. So there's a proprietary element to the encoding and decoding. The QR code piece would be vanilla QR code standardization. A third variation, not put an image on the QR code at all, but instead put a face recognition template on the QR code. Now, templates tend to be smaller. They can be smaller at high accuracy. Many face recognition templates are 2, 3, 4 kilobytes, and they would be inappropriate for this kind of vehicle. Clearly, with a template, you're not expecting to decode that or invert that. You send it direct to matching. And again, all of this matching would be done with a proprietary implementation, proprietary matcher, but potentially faster. So we've got these three ways of doing business, and I'm going to talk about the first one. So we want to make a small face suitable for a QR code. To do that, we take an enrollment quality image, say destined for a passport or for some other credential, national ID database maybe, and then we are going to detect the face within that scene and crop it out. Then we're going to expand that crop a little bit to give you coverage of the face, full coverage. We then crop that out, we resize it to a small size, maybe 80 pixels, 96 pixels wide, and then we send it to a standardized compressor. And the compressors are lossy, and there are a number of them, which I'll get to on the next slide. So that tool chain, that process, there's a few variations that we can conceive of. How much margin around the face? Do we fix any rotation in plane? Do we take care of aliasing when we go to a small size? How do we go to a small size? Using what algorithm? What's our target width at the end? Are we going to do this in grayscale, black and white images, or full 24-bit color? And then which compressor will we use? There are many compressors going back many years, most of them standardized in SC29. But those various options, we surveyed over those, and I'm going to publish a report soon giving the results of that survey. But a sneak preview. The target file size here is 960 bytes. That is about the right size for a barcode that would fit on a 7816 size card. JPEG, for those of you sat at the back of the room, the JPEG images at the top of this slide, they may look good to you, but for the people sat at the front of this room, they look very compressed with very characteristic artifacts. On the bottom row, we have compression from HEIC and WebP and AVIF, which are much more modern image compression codecs. Now, all of these are lossy, and they do damage essentially to a face. They remove high-frequency spatial information. That will have an effect on face recognition, and it will have an effect on human perception. A bigger issue when you use a standardized image encoder, compressor, is IP, intellectual property, open source, and cost, which I'll get to in just a minute. A lot of standards in play here. I thought I understood this microphone, but I don't. It has a mind of its own. So JPEG, JPEG 2000, HEIC, AVIF, all available. Some are much more widely supported than others. WebP images, AVIF images can be opened in many web browsers today. HEIC less so, JPEG 2000 less so. Okay, so I move on. Now here come, we did have some results, but we lost the results. What you're going to see are recognition accuracies, how often authentication fails. Red is bad, blue is good. 4 different recognition algorithms across the panels at different target sizes within each panel, down to 600 bytes. And then for 5 different compressors. And you can see that JPEG is almost catastrophic. You cannot use JPEG except in very limited circumstances. Much more viably, with all the recognition algorithms, we do not incur big accuracy losses if we stay above 960 bytes or thereabouts. Below that, recognition failure rates start to increase. At 600 bytes, most of the recognition algorithms will fail. Will begin to fail quite seriously. So this is maybe not a precise view of the landscape here, but it's pretty good. Now, if recognition were to, if we, in a future world, we have these QR codes fully interoperable, you can read them, and suppose, for example, somebody presented poorly to the camera and the authentication against the QR code failed. You might go to an attending operator and say, please, the recognition failed, what do we do? Now, the human would look at that. The conventional wisdom in most access control operations is that it falls into the lap of a human, and that is problematic because humans don't like to look at these images. And so we don't want to do too much lossy compression. So that's a topic. But the default encoding so far that we've come up with, a recommendation if you like, would be 960 bytes at 96 pixels width, maybe 120 pixels vertically, using a WebP compressor because of its royalty-free and wide availability, and to use a recent face recognition algorithm, so the last couple of years. If you do that, and you reside in that blue square here, taking care to prepare the image in the right way, then you don't really incur recognition accuracy losses. So the summary in the last 1 minute, compact face images can be made without significant accuracy decrease. WebP, HEIC, and AVIF will get you there. JPEG will not. WebP is maybe preferable because of its licensing and royalty-free nature. There's a story there with Google that you might want to look at, involving Google, because they invented this. Human reviewer accuracy is maybe something you might need to take care of in certain circumstances. A key point here, and we impressed upon you this morning, that there's no point in going down this road if the image that you use wasn't trusted in the first place. If it's an attack image or a morph image, once you compress it, you're going to be very difficult to detect that attack. So trust the capture here. We have a forthcoming report, and the key point, the key takeaway here is fully standardized processing from an authoritative reference image down to a QR code. And with that, I'm finished.
Thanks, Patrick. We're really fortunate to have one of the heads of, the head of cybersecurity for the Ethiopian program coming next. I'm really excited to hear this, and so without further ado, I'll hand you over to Mr. Biu.
Thank you very much. Good afternoon, ladies and gentlemen. First of all, I would like to say welcome to the wonderful city of Addis Ababa, Ethiopia. On behalf of National ID Program of Ethiopia, we are very much pleased to see you all here in the beautiful city of Addis, and I hope you are enjoying your time. So coming to my presentation, it's about the FIDA's VDS. I'm very much privileged to be on behalf of near to these experts as a speaker. So my name is Kasai Tafesa. I am head of cybersecurity at National ID Program of Ethiopia. To start with, the very critical purpose of a national identity system, we have two services. One is registration, where we ensure everyone is included in the national ID database. And the true use case of national ID comes with authentication. So there comes the use of FIDA VDS. VDS is visible digital seal. So the main purpose of the FIDA VDS is to ensure authenticity and integrity of the FIDA issued credentials, especially for offline use cases. So our VDS binds individuals to the credentials, meaning that we have the face template included in the QR of our VDS that I will show you in the upcoming slides. So it can be usable in electronic format, and also more importantly, it's useful in printed formats. So our VDS, inspired by the ICAO VDS that you have seen earlier, it is a well-structured data set, and it's signed by the national PKI, and it is encoded into the barcodes. So verification, as I mentioned, since we have managed to put the face template into the QR, so we are also enabling the verification through face biometrics. So it supports online and offline. As I mentioned earlier, it's more useful for us for offline authentication, because for countries like us where a remote area we don't have enough connection, it is important. At FIDA, we do have different credentials. At the top, you see there is a physical card, which we do print, but equally important and usable, we have the soft copy. One can have his credential in PDF format. Again, we have our FIDA mobile app, so we can have our credentials embedded in our mobile application. So as I mentioned earlier, it can be verified both online and offline. Coming up to the whole process of our VDS generation, it all starts from the secure identity repository, where every data is stored in secure manner in encrypted format backed by hardware security modules. So we encode with the standard JSON, but as you have heard, there is a resource constraint environment, especially for printable credentials on physical cards. We preferred to use the CBOR binary format, which is concise binary object representation. And again, for the sake of security, since I mentioned, it is very important to ensure authenticity and integrity, we used the CBOR object signing and encryption. So I'm very much happy to hear that it is recommended to use WIPI by the NIST, so we already did use the WIPI compression, and we have found a good result. So everything will be embedded into the QR and will be signed by the COSE, as you can see. Then later on, we embed the public certificate on the mobile application for later verification. There are 5 components important in our FIDA VDS. The first one is credential. As I mentioned, our credentials are stored securely in FIDA database, which is very important. So only authorized and authenticated internal services will be able to access the credentials. Then again, by having this 2D barcode generator, we managed to put those credentials into the barcode. I already mentioned that we have the face template for later face authentication. Then the very important part is credential issuer, which signs our VDS by using the private key residing in the HSM physical devices. So we have also considered and implemented a trust framework, which I will explain in the upcoming slide. The overall FIDA VDS structure follows the ICAO VDS, which has been used for the last the COVID times, especially for health credentials. So as you can see, there are 3 components: the header to embed some metadata, including the algorithm we use, and the payload. Here, most importantly, we are lucky enough and very thankful for the MOSIP and Tech 5 team to come up with the MOSIP 169 claim. This makes our FIDA usable across borders, because this is a standardized format inspired by the CBOR, where the identity claims will be stored as per the specified. So lastly, we have a digital signature. As I mentioned, we have integrated with the national PKI. We are also very much happy. Our national PKI is fully operational and issuing digital certificate for our electronic passport. We did use the same PKI structure. So just to explain the way we encode the digital seal, as I mentioned, there is a demographic and face biometric specifically data, and also face template encoded compressed by the WIPI, and the digital signature using the private key residing in the HSM. Everything will be encoded by our 2D barcode generator, and especially useful for printable credentials. The seal validation is pretty much a reverse process. We scan the QR code and decode the format. Then we take the face of the individual. Then we compare the face template. Again, we confirm the integrity and authenticity of our credential using the private key. So that this adds another advantage of usability for higher level of assurance, especially for offline applications. The most important aspect of this kind of credential is the trust framework I mentioned earlier. We have a national fully operational PKI infrastructure. So at the top of root, you can see country signing certificate authority, which resides in national PKI. It issues or signs a certificate which resides in our national ID platform, barcode signer, and later on we use this barcode signer to sign every credential issued by FIDA, including this VDS. Just to showcase what quality of image we managed to put in the QR, the left side is me, the actual photo of myself in FIDA VDS. So the original photo and compressed one, as you can see, it can be simply identified. I hope we managed to get pretty much good quality for our use case. These are a couple of my colleagues, just to showcase the quality of photo we manage. I have more photos, just to showcase we are privacy concerned. I just hide their eyes. Finally, we did comparison using the matrix. The left one, you see, ROC metric analysis, comparing the original uncompressed image with the compressed image. So the x-axis represents the false acceptance rate, and the y-axis represents the true acceptance rate. As you can see from the graph, we have managed to get 90 to 95 true acceptance rates for 1 in 100,000 false acceptance rate. To your right, the blue one represents the original uncompressed image based on the Briscoe score, which is like as a Briscoe matrix, the lower is the better. So the original photo lies from 0 to 30, but the compressed photo centered around 45 still looks good for our use case, but we are also looking for another techniques to have a good quality of photo in our VDS. That wraps my presentation. Thank you very much.
Thank you. You're not going to get away that easily because we've had a specific question in about enrollments into the system at the moment and your rollout plans. Could you just address that one? How many people are enrolled in the systems, and what's the sort of like plan to roll it out across the population?
Yeah, the population. Okay. How many? So, thank you for that opportunity. I think my executive director has already mentioned Tuesday morning that we have surpassed 50 million registration, and we are pushing it hard to have over 90 million registration in the coming few years. Yeah.
Thanks very much. I think that I just wanted to make sure that number went out there again because it's an impressive piece of work, and I think it shows the strength of the sort of panel here that you've gone from us that talk about things to yourself who actually does things. It's a great testament to the work that you've been doing. So thank you very much.
Thank you very much.
So our next speaker, again, is coming from the perspective of national ID systems. So Mr. Choje, I wonder if you can take us through what you've been doing with your work.
Distinguished guests, ladies and gentlemen, good afternoon. Before I begin my presentation, I'd like to extend my sincere gratitude to Dr. Atik and ID4 Africa team for giving me this opportunity to present in this forum. And I'm deeply honored and privileged to share this stage with industry leaders, regulators and domain experts. Special mention goes to Mr. Oitz. He has been with us in the initial phase of our digital identity journey. And my name is Theong Choje, and I work with the government of Bhutan. I work in the GovTech agency, and I'm here to share you our experience of using digital identity as a trust framework in a decentralized manner. So sorry about the slides. I have a lot of words, but I'll try to simplify things. And just to mention that we are not the first country to fully adopt decentralized identity, but nationwide, of course, we are, and we did it only a few years back, 2 years back in 2023, and that wasn't really because of the technology. It is also partially because we had a strong legal framework put in place, and we have passed our NDI Act through the Parliament in 2023, and technically, we have a very simple and secure mobile wallet system that use biometric verification to store your personal information and also to share your personal information. And today, national identity in Bhutan has become the bedrock foundation for digital transformation in Bhutan, empowering people to have easy access to services, and in the government it has improved efficiency, and this is now a cornerstone of digital strategy in Bhutan. So by now you know what VCs are. When we talk about decentralization, this is the core component, and I'm sure VC works both in centralized as well as in decentralized methods. But at the end of the day, verifiable credentials has to be cryptographically verified for its authenticity and integrity. And as we use more and more VCs, our citizens now has almost like 40-50 verifiable credentials in their wallet. And think about using it across different states at the national level and even beyond the borders. And that's where interoperability comes into picture. And that's why the standards are important. And it happened to us that we use W3C standards in Bhutan. And talking about the trust triangle, so this is where my main topic is. So in every decentralized methodology, there are three key components: issuer, holder, and the verifier. So in the Bhutan's trust framework, we have something called trust registry, where we have all the officially trusted and legitimate authorities issuing verifiable credentials. And when you as a citizen present the credentials, the verifiers doesn't believe you. So two things happen here. So one is the verifier checks whether the verifiable credential is being issued by the legitimate issuer, and the other thing is that you check for the authenticity of the data. So I'll not go into deep about decentralization and centralization because a lot of speakers has already talked about pros and cons about this, but every country is different. For us, we have our own set of challenges. For example, our country is small and mountainous. We have challenges in connectivity. We have challenges in digital literacy. Also have challenge access to public services. And considering our legal framework put in place, as well as the kind of identity systems that we have, decentralization has given us more advantage, particularly in terms of data control by the citizens. And technically, we ensure that the citizens' data are put even to their own devices and securely, and that kind of solves single point of failure. And it also fosters a lot of open ecosystem where multiple agencies work as both issuer as well as verifier. And privacy and consent remains at the heart of everything. So we use something called selective disclosure, where we present only the minimal information required to access the service. So, so how does it work actually? Maybe I'll take an analogy of traffic police stopping you to present your driving license. So in physical world, it happens in two ways. The traffic police checks whether that driving license has been issued by the legitimate issuer. In our case, it's transport authority that issues the license. And it also checks whether the license is valid. So the same thing happens here. When the traffic police stops you, you present your verifiable credential, and the verifier, the traffic police, their app will check whether the verifiable credential you presented has been issued by the competent authority, and it also checks whether that verifiable credential is valid. So based on these kind of use cases, what we have done is we have integrated Bhutan NDI in hundreds of government to citizen services. Especially we have enabled passwordless login to this, and this has actually opened up a lot of opportunities. Especially in our case, our service provider usually asks for a photocopy, physical photocopy of your identity, just to prove that it's you who came there to avail the service. So now that we are using verifiable credentials, we don't have to submit this physical papers anymore, and it cut down a lot of bureaucratic delays, and it enables us instant verification. So because of this, today I'm happy to share that we are now able to open bank account remotely without even going to the bank, going to the counter. And these are some of the use cases in financial and private sector. Major banks in Bhutan are already onboarded to Bhutan national identity, and we have two major telecom operators, both onboarded. We have many companies under Druk Holding and Investment, big companies. So they primarily use for electronic know your customer. And as I've said, remote account opening, and we can book your SIM cards online. This applies to both Bhutanese national as well as foreign nationals, so you don't have to physically go there. You can get your eSIM directly from their website. And of course, we have a lot of HR and employment and onboarding use cases. And these are some of the screenshots that I've included here. This is the Bank of Bhutan, where you open your bank account virtually. And this is the Bhutan Development Bank, where we have enabled both account opening as well as eKYC. And this is another private bank allowing you to open your bank account. Telecom operator, private telecom operator, allowing you to book your SIM online. And this is the transport authority, where we have driving licenses, issued as a verifiable credential. So the case of driving license I've explained enough, but what happens is in terms of the validity of your verifiable credentials, two things happen. So your verifiable credentials are updated in two ways. One, most of the credentials have expiry date. For example, passport has an expiry date. Your digital, identity card has an expiry date. Even a driving license has an expiry date. As soon as you reach the expiry, the verifiable credentials get revoked automatically. And the other way the verifiable credentials are updated is, for some reason, authorities revoke your own verifiable credentials. So we do this by using something called a revocation service. So we have two components. One is the trust registry and the revocation service. So just to summarize everything that I have talked about, Bhutan is fairly a small country, and for us, given that considering all the legal, regulatory requirements, the challenges we face, and also the kind of identity systems that we have, it has proven that decentralized kind of identity works for us, and we believe that this works for a larger country with bigger population. And from our experience, two things are very, very essential in having the digital identity implemented smoothly. One, first and foremost, is strong legal and governance framework. That's very essential. And the other one is strong leadership, visionary leadership and strong support from your leaders. But for us, fortunately, we are blessed with both visionary leadership as well as good legal frameworks put in place. So if you have these two, I'm sure you will have a smooth scale in implementing digital identity across the nation. So I want before I end my presentation, I want to show you statistics on where we are currently. We have successfully onboarded 311, close to 11,000 citizens. So that's a very small number, maybe in your country, but for a population less than 1 million, this crosses around 50% of our eligible population. And we could do this within just 1.5 years, and this is a big achievement for us. And we also have 50 plus electronic services integrated with the Bhutan digital identity, and that also excludes 100 of G2C services that we provide through the through a single portal. And moving forward, we are making our verifiable credentials interoperable across the region. So we are working towards that, and I'm pleased to extend the interoperability across African region as well. And I firmly believe that by enabling seamless, secure, and trusted identity verification, we can empower citizens with greater access to services, enhance trust in digital transactions, and ultimately add meaningful value to their daily lives. Thank you very much for listening, and I'll be ready to take your questions. Thank you.
So we've had one that's come straight through actually for you, which is that noting your SSI description of the DID wallet in Bhutan, does this mean that VCs cannot be modified or revoked by the issuer?
Yes, the concept of VC I've explained earlier. So the revocation happens through what is called a revocation service. So as I've explained, maybe I'll repeat it again. It happens in 2 ways. One, when it reaches its expiry, it gets revoked. And the other one is when the service, for some reason, service providers revoke your access. Maybe if you're drunk and if you're driving, police will revoke your driving license. So in such cases, the revocation happens with the verifiable credentials.
Thank you. And we now come to our final speaker, who's going to take us through again some of the more practical implementations.
Hey everybody again. Thanks for Joseph again for us having here. And I also want to thank you to ICAO, because I really love the ICAO work, what they do. I have been very passionate about seeing when it comes out. And by the way, Europe Commission already has for the Parliament prepared a bill to recognize TTC and TTA under the EUD wallet. So we're kind of waiting, I think. I'm not sure if that's the reason, but maybe we're waiting that everything is ready and then it goes. So also about Bhutan, I was lucky to work with them 1 year. I lived during the COVID in Bhutan, and that was a fantastic time. But I left also there because I didn't believe into that SSI approach, what they technically has chosen. And I still have suspicions all over the world that SSI doesn't work, but I'm really happy that we have use case which in Bhutan context works. So my slides, please. Maybe I can have those.
Okay, while we're waiting for the slides to come up, let's try and kill off some more of the questions that we've got that were more specific. Again, from the Bhutan system, how did you choose the decentralized identity model, considering it's not easy for government to see its benefits? Any motivations behind that?
The advantages of decentralization has already been explained. So the very reason why we have gone with decentralization is mainly because of the challenges that we have currently and what kind of issues that we are trying to solve. And considering we had a very strong identity system already 20, 30 years back, but that was more or less like a physical. Every citizen had a booklet. It wasn't a card, it was a booklet when we started initially. So, but we had a very robust identity database in place, and the use of identity was very much, we were using identity system across the services. So we have considered everything, and then we also had the National Digital Identity Act that mandates to have more of a decentralized approach. So these are some of the reasons that we have gone ahead with the decentralization approaches, and we could see some results immediately, and we are also moving towards having more robust use cases and implementation with the decentralized kind of methods.
Thank you for that. And we've got the slides up, so we'll go straight across. If we could reset the clock again.
Thank you. I love a little bit more time. So my idea initially was to talk about specifically about verifiable credentials based on the standard W3C one, but I decided that I'm approaching more general level. I'm talking about overall credentials and the problems what we have with credentials and problems what we might face in the future if we don't make right structural decisions. So before Bhutan, I worked with Singaporean government with the SingPass program. I went to Bhutan because of His Majesty, beautiful vision. And what I loved in specific in Bhutan that he really believes that technology can help and support the country. And that was one of the reasons I went to Bhutan. And I believe that if every country can have this type of leader who believes that with technology they can help the nation, then this is beautiful, and I really love it. So, in Bhutan context, we discussed also one of the use case basically, which is the crossing the border. What is the data we need? We have the person, we have the info, we have the credentials, we have verification, we have border office. The biggest problem with every credential today in the world is that, okay, not with every, but with most of them, that they are not verifiable during the post-presentation period. Exactly the same question, that if you're not able to revoke the credential, then the data is not usable because you are not sure that this data is valid or not. Then other use case is basically that if you're storing the data into the blockchain, and the data stores also, the data includes also the personal identification information, then in European context, we're going to see on 7th June directive from the European, I think it was European Data Protection Advisory Board or something like this, which will guide countries not to store any PID to the credentials, sorry, to the blockchain if you are not able to remove it from there. So they're not going to mention the technology specifically, but it's clear that it's about the blockchain, because if you are not able to remove it from the chain, then there is a problem. So I have seen many implementations which over the last 5 years has been kind of showed to me, and I need to say that at least half of them still storing the credential information into the blockchain. It means that the issuing certificate and the storing the same data for the integrity purpose to the chains. Then we have different formats. We have the ICAO formats, we have the ISO formats, we have ETSI formats, we have the old ITU formats, 6509 certificates, we have different standards. And one of the questions is that In today, we're using, like in Microsoft context, we're using Microsoft software. For XMLs, basically, which is also Word document, we're using mostly Microsoft or Google Docs these days online, and PDF games for archiving purposes mostly, but it is good to use every day also. Now, we're going to have the same situation with all the credentials, and that's good. I don't see the problem that we have more than one standard or more than one type. I think we need to allow to innovate, but we have specific requirements to all those credentials. This is something that we need to remember. And if we're basically talking about trust of specific credentials, then it doesn't matter how good is the technical implementation or how poor is it. The main question is that based on what the other country can trust your identity during the immigration process. And mostly, before the technology is agreed, there shall be bilateral agreement and will to recognize the credentials. And again, it doesn't matter what is the purpose for what the credential is issued. It's a credential. And we don't want to see a situation that maybe Europe will recognize, okay, it's not going to happen that way, but in this photo, basically, which is delivered by AI, it's a use case where ICAO-compliant credentials accepted only. We don't want to have this situation. And that's the reason why we really need to think about interoperability and recognition already today. And this means we need to have proper governance model. And this is not only about Europe, this is about worldwide. And we need to resolve the problem quite soon. So, again, technical trust. My biggest question all the time, speaking with countries and also with vendors, is that why we need to have, after credential, when it's issued, also the consent if we're sharing the data. During the morning session, we discussed about data interoperability, and about data interoperability platforms what we have in the world. And I told the audience, to you guys, that this is about infrastructure. The wallet is not just a wallet, it's a data exchange layer. The same like Xload, which was showed before during the morning, and many others. And wallets includes the data, and this data can be shared only with consent. Now, the main thing is also that in country, if you don't trust the credential, and if the court tells you that this type of technology is not usable, then what you're going to do? What I have seen in Africa and in many other countries, that many privacy questions are rising, and this is the reason that the initial architecture is not delivered based on the actual needs. Technology comes before the legal framework. So somehow this is a common way how things are happening in the world. So I asked my son, so how to present this type of information to you? And he has some kind of math exam today also, so then he proposed that I have the formula for that. So I have formula. For the proper interoperability for the credentials, doesn't matter what's the system, we need to use unique identifiers. Previously, I have been mentioning also that identifier shall be public, not a secret. And all the data and attributes shall be linked with the identifier, not in opposite way. Now, taxonomy. Even if we have the technical interoperability in place, then one of the biggest problems with different formats, with different countries, different languages, we're going to have with taxonomy. We need to agree on rules. We need to agree also which kind of sources are trusted, what we can trust and what we cannot. In European context, we have resolved the problem in a way that we have trusted data sources and non-trusted. We're calling qualified and non-qualified. We also need to agree who is the issuer. Because in the cycle in Europe, we have the claim which comes in, which will be signed by the relying party. Then we need to approve the claim, and then we're sending request to the relying party, sorry, to the authoritative data source. We're getting data from there, and if we have the data, then the data is signed, but the claim claim attestation in Europe, it's attestation, not a credential, and consent shall be binded with real individual in that specific transaction. Now, if we have the credential format also agreed, and we have the consent in place, and we have model how we can verify the attestation or credential validity, then we don't have any more problems. And now if all those technical things are in place, we can have the legal recognition by the legal frameworks. And mostly this again expects proper data governance. And I think for you guys and for any other country to implement ICAO digital credentials, the legal recognition comes after everything is placed. But we need to have the business requirements before when we're starting to work. And now, if the legal framework supports, technical part is okay, and then it's acceptable. And then we are okay to proceed. Thank you.
Thanks very much. So we've been true to our word. We've given plenty of time for questions, so I'm going to try and capture some of these and get them across to the speakers, and with a bit of luck we'll get through quite a few of them. Starting off with Christopher and ICAO. Do you have a roadmap for your DDC implementation and deployment? And if so, how are you going to ensure compatibility across DDC 1, 2, 3, particularly when you've got different infrastructures at different locations?
Okay, thank you for the question. In terms of a roadmap for deployment or implementation, I would say, if you give me a yes or a no, I would say we don't and we won't, because our role is really to stay above that a little bit. Our job is to set the framework, do technical work in terms of specifications that go into Doc 9303, and then sort of say, ensure or encourage that states follow these specifications, which will then create interoperability. So, and in terms of regulatory aspects, actually that's the first thing I said as I came here, is that, you know, we're a long way off from there being a regulatory obligation to do the DTC. That's not happening as we speak by any means. So for example, we didn't do that for the e-passport, but the uptake was considerable, and now we have more than 150 states implementing the e-passport. And so that, you know, technology, we set those specifications, and then we allow the states to implement them on their needs, on their use cases, and how they can benefit from that. Yeah.
Thanks very much. Moving on the line then, Patrick, we've got a question about WebP and JPEG 2000. How do they compare in terms of photo size and quality when used in QR preparation?
Yeah, good question. The code for including JPEG 2000 in our survey over compression algorithms was written last week. We don't have results yet. We will have results in the future. JPEG 2000 is, of course, widely deployed in border crossing because ICAO specifications, but we didn't prioritize its implementation in our study, so I can't give you an answer at this time.
Thanks for that. Okay, moving on. How is Ethiopia's national ID scheme prepared to handle offline certificate revocation and prevent replay attacks in rural areas with limited connectivity? That sounds like a very detailed one.
Okay.
Thank you. Very nice question. As I mentioned in my presentation, our digital signature has already been integrated with our national PKI. So at national PKI, they have a policy as part of their certificate practice statement. They will issue the certificate revocation list every 90 days, even if there is no any revocation. But for any revocation case, they will issue a list immediately. So the verifier app that we have in our mobile application would constantly check to that CRL to get the list and make sure the certificate hasn't been revoked. Because it is completely offline, we cannot use the OCSP protocol, so the only option we have is the certificate revocation list. Thank you.
Thank you. I'm just going to jump to Otto. Is in extreme edge decentralized systems, how do you provide high availability, including disaster recovery, for everyone's wallet? You wanted a difficult question.
Can I have country and specific conditions what we have then? And what is the wallet and which type of formats and so on they're using? I need to have more information. But if you have the name of the person, I'm happy to have a conversation about that after that. And maybe I can publish that in my blog then.
That's fine. I'm sure they will catch you afterwards. You're a marked man now.
Good.
Thanks very much. So moving on again, there's a couple of questions about the patents situation and IP around, particularly around standards development. I'll take the first bit of it. And it really, one of the things that, you know, when these standards are developed, and this is really coming from an ISO framework, one of the things that the experts have to do is to declare up front whether they're bringing in any patented material or anything that's going to cause issues in terms of the dissemination of the standards. Now, in reality, what happens is that people just don't bring anything in there that's going to go down that patented route. So that's something that I've seen in a couple of instances where an expert's declared something as being commercially sensitive, and it hasn't been included in the standards that goes forward. So, Patrick, did you have any other thoughts on IP and standards and how we prevent it?
IP has existed in standards for a long time. For example, MP3, encoding an MP3 file if you're a music studio and disseminating it, you pay royalties. At least you did. I don't know if you still do. For decoding the MP3, that's a free process. But MP3 is standardized in SC29, in a standard that I can't remember. But yeah, it's common in media, multimedia context for IP, but also in other domains. And it's essentially unavoidable. ISO essentially doesn't touch the topic. There's a declaration which, as Peter pointed out, may or may not be complete.
Thanks. We've had a question in on blockchain and whether any of the implementation, so I guess it's the three at the far end, have looked at blockchain. They think that's going to give them any kind of advantages in terms of transparency or you know, effectively auditability. So if we start off with yourself.
Okay, thank you. So in our FIDA ID, so far we haven't used the blockchain technologies, but I hope in the near future we'll look into it, because we are coming up with the new mobile wallet for credential storing called FIDA Pass. So we will consider that and check, but the decision comes between the advantage and disadvantage. So far we haven't used it. Thank you.
Thanks. Bhutan, is that being considered in your system?
Okay. Thank you for the question. So it's in relation to blockchain. Yes, in a decentralized approach, I think more or less everyone use blockchain. Even for us, we use blockchain, especially in terms of recording the trust registries and also ensuring that the schemas of the verifiable credentials are already on the blockchain. So blockchain is actually ensures that the schemas are not tampered, and that's being used by the verifier to verify, especially on the integrity of data. So we use blockchain for those purposes. Thank you.
Thank you. Also, have you got anything to add?
So my comment about European approach and storing PID into the blockchain is problematic. Is applicable only for the use cases which is going under the privacy law. Because at the same time with the privacy laws, we also have special laws which will allow us to store specific information to the databases. So we need to be clear that this is in valid context. If we're storing the PID for integrity purposes as a logs or something like this, then this is not recommended, because if you don't use this type of software or wallet anymore, then service provider is not able to remove that data from their system. That's the problem. There is no hate to the blockchain or SSI or something like this. This is just a technical issue. If your privacy law expects that consent can be revoked, and revoking means that data shall be removed from the database, then that's the use case which shall be followed. That's all.
Okay, I guess following on from that, there's another question which is specifically for you, which is to strengthen efforts in ensuring privacy protection across sectors, how can we address consent issues in QR code development and challenges of tokenization?
Rules are same to everyone. Doesn't matter what is the implementation or what is the domain, except if there is a special legal act which allows to treat data differently.
Thank you. A question here for ICAO is, and this may just be a quick one, is there a collaboration between CETA and ICAO on systems?
Not specifically. The CETA is a very reputable vendor and company, and they support us in our Traveler Identification Program Symposium. We have dialogue with them on, terms and so forth, and that's very good. And they've been a traditional partner for aviation, and especially in terms of passenger data, but and border management. But I'm sure they'll be one of the ones working with all the specifications that are coming out.
Great, thanks very much. And I guess that bell means that we should be wrapping up at this point. Dr. Attic will probably drag me off if I don't.
No, Dr. Waggett, you actually have 5 more minutes.
Oh, okay. Sorry about that then. Has anybody got any particular favorites in terms of digital travel authorization use cases that they think will be valuable in terms of some of these things? I know you covered quite a few of yours.
So the DTA, in our vision, is there to replace the e-visa. So to standardize that term and to standardize the barcode that countries use for that. Some countries use barcodes as pointers, so it's not even a payload there, it's a pointer to the internet, which makes it even more difficult for airlines or states to verify. And again, so our buy-in is that if you're invested into EM or into electronic machine-readable travel documents, invested into our cryptography, our PKI, you can redeploy that hopefully into our specifications, which now include a facial image and so forth, and protect that through this common PKI, which can be distributed via the public key directory, and makes it more and easier and globally interoperable to validate. Yeah, and I wanted to pick up on there was another question on the DTC. How do we ensure interoperability between the 3 pillars, between the 3 types? And that's written into the specifications. So in all cases, there has to be the virtual component and then the physical component. And all of them are programmed to identify themselves to the inspection system as being either a passport booklet as a physical component or if it's a phone or whatever, it identifies itself as a DTC. So that the inspection system knows what it's receiving, how to read it, and how to validate it. And that, will have to be anchored into the existing near-field communication standardization for borders, so that we don't incur massive costs at borders when we're presenting tokens then.
Thank you. We've got time for one last one, I think, which will have to be quick because it's addressed to both Ethiopia and Bhutan. How can you counter deep fakes in your digital IDs? Have you got any mechanisms in place to look at that, or is this something that is evolving? Sorry? How do you counter deep fakes?
Hello. Okay, so the deep fake, I think that's kind of emerging, and I think it poses threats to more or less all security measures, and I've been told that it can also fake the liveliness check of liveliness check in terms of biometric verifications. This is something I think the biometric vendors should answer the question, but we, at this point of time, what we do is in the transactions, we have divided different kind of transactions. So it really depends on the value of transaction that you have in your system. So using the digital identity, it's not really with the defect, but it's quite similar. So I want to explain to you this because I think this will have a use case in your situation as well. For example, you just apply for a service which doesn't really have a big value. So in such cases, liveliness check and all this thing, all this kind of high security is not really necessary. That's what we felt. And deepfake, if you have not implemented liveliness check, there is no question about the security in this case. And where we use liveliness check is in the high value transactions. For example, you are selling a property or a land. In such cases, we use liveliness check, and we also use liveliness check in areas such as pension. Some people could be dead, but the other person could still be having benefits. So in such cases, we use liveliness check, but the actual question about how we resolve these kind of issues, I will leave this to the biometric vendors. Thank you.
Thank you very much. I think we had a couple more people want to just make quick points.
Our time is over already, but we didn't mention today X509 certificate. So as I'm Estonian, the digital identity what we have in place is already last 20 even more years. I'm using it every day. We have three types of eID schemes. We have the smart card, we have the mobile app, and we have the SIM card based. Now, in every transaction, we're giving the same X509 credential to relying party. This is not something new in our ecosystem. And I believe that while everyone's building the wallet, sometimes we need to simplify the concept to understand it. It's just giving data from one party to other party. Two options, having consent, second option, don't have the consent requirement. Thank you.
Thanks for that. Can I just ask you to thank all the speakers, and I would like to thank all of you for your questions.